Hello class, let's cover our last section for this second week that I am gone. I look forward to being with you next Monday. And this is on transformations of functions, section 1.7 on page 67, if you would turn there. Okay, so we are going to take the basic parent functions that we learned back in section 1.6. You can flip back if you like to look at those. Let me see. Yes, that's not quite it. But anyway, you can look back at those if you like. And then we're going to do transformations. So there are transformations that are vertical slides, horizontal slides, reflections where things are flipped either over the x-axis or over the y-axis. Maybe you learned these when you studied geometry. And then there are also dilations where things get larger or they get smaller. Okay, so in this summary box is a breakdown. A vertical shift of C units up would be adding a number to the function. C units down, subtract. Now this is what's interesting. To slide the function to the right, you do a minus C inside the parentheses. I'll show you what I mean by that. So this is counterintuitive because we're going to the right, but it's a minus C. And then to go to the left, it's a plus C. What you could try on your graphing calculator simply is to just try this out. Okay, so let's clear this out. Let's go up to our y equal and clear this out. So let's take our basic function of x squared, okay? So if I have y equals x squared plus 3, and I wanted to, whoops, that's not right. I do that sometimes. Delete, scooch over first, plus 3. So which way would this shift our parabola? Plus 3 is going to move this parabola up. And if I went down here and did y equals x squared minus 3, which way would that shift? That would shift the graph down. Now let's go back and do, this is a nice way to compare, in parentheses, x plus 3 quantity squared. Can you guess which way this should shift? I just told you, plus is going to move to the left. And if we graphed the last option, parentheses x minus 3 quantity squared, that would shift the graph to the right. So it's interesting to have those all on the graph at the same time. Some of your calculators might have those in different colors, which is very interesting. All right, so the summary for vertical and horizontal shifts, sometimes called slides, is right there. So you need to be familiar with the parent function. So for instance, y equals x cubed looks like this. So x cubed minus 1 is going to shift that point down 1. And every point that, and from there, all that we're interested in is sketching a graph. Notice we're not making any table of values. We're not even using our graphing calculator, right? We're using our minds to understand which way would that shift. Y equals x cubed is our parent function. We know the shape. So x plus 2 plus, counterintuitive, remember, when it's inside the parentheses, goes left 2, boom, boom. So instead of crossing at 0, 0, it's going to cross at negative 2, but we also have a horizontal shift of 1, boom. So this point has slid there. We have two things going on. We've shifted left 2 and up 1. And then we just sketch the basic shape of it. All right, the next thing that we are going to talk about is reflecting a graph. So reflection is when something flips or reflects over one of the axes. Usually you can also reflect over a line, but this is reflecting over an axis. And what do? We put a negative out front, and that's going to reflect this graph over the x-axis. So if we have y equals x squared, that's our parent function, our plain vanilla function. Y equals negative x squared, that would be flipped over, a reflection. Now, what's interesting is when you put the negative inside the parentheses, that's a reflection over the y. Well, let's take a look at this. What would happen to this function if we reflected it over the y-axis? Since it is symmetric with the y, it looks exactly the same. And we know with the definition of an even function that f of 2 equals f of negative 2, right? So it's going to look exactly the same. All right, so you can look through here, experiment with this a bit, try and get a handle on things. Let's look at this parent function, y equals the square root of x. We know it looks like this, right? So if y is equal to the negative square root of x, that's going to reflect it over the x-axis. And what happens when we put it on the inside? That reflects it over the y-axis. Pretty interesting. So challenge yourself to see if you can anticipate some of those. And like I said, several will have more than one shift. Okay, what does non-grid transformation mean? Some people call this a dilation. Here is the parent function of y is equal to the absolute value of x. It looks like a v. If you were to multiply everything by 3, does it make sense to you that our slope is 3 times as steep? I hope so. If we multiplied by 1/3, then our slope would be 1/3. It's going to go up slower, right? Okay, so what does this mean? This paragraph right here, I think, is just a little confusing. From here to here, we call that a vertical stretch. Think of it like this. Think if you took the ends of this and vertically you stretched it up, it would become this function. Now, a vertical stretch is also called a horizontal shrink. So it depends on how you look at it. And how we normally look at it is if the coefficient is outside the function, we call that a vertical stretch or a vertical shrink. If your coefficient is between 0 and 1, it's going to be a fraction, that's a vertical shrink or compression. Some books will say a vertical compression because you're pushing it down. Now, if you take that same number and you put it inside the parentheses, we start talking about a horizontal. Horizontally, what's happening? Well, this is still a vertical stretch. So let's say if we're vertically stretching, what are we doing horizontally to this function? This one is a little bit easier to see. We vertically stretch this. Do you see how it's a horizontal shrink or compression? So you can read this, they talk about the C. If the C is greater than 1, blah, blah, blah. Do read this. It's a little confusing. But what it means is when the coefficient is inside the grouping symbols, then we are either going to have a horizontal shrink or a horizontal stretch. So this would be a horizontal stretch. Vertical shrink is the same as a horizontal stretch. In fact, I wrote that in my notes right here. A vertical stretch is the same as a horizontal shrink, and a vertical shrink is the same as a horizontal stretch. So when do we talk about vertical? When the coefficient is outside the grouping. When do we call it vertical? Vertical. When do we call it horizontal? When the coefficient is inside the grouping. Okay, so I hope that that's a pretty good explanation. Again, I'll be back next Monday. If you have any questions, we'll save them till then. Look forward to seeing you.